Okay, so we're going to go ahead and review a little bit of our AND statements and OR. Our AND statements are the intersection or overlapping. And as an inequality, it's going to look like this, like x is greater than 4 and x is less than 9, or they're going to get put together in one inequality. So when you graph it, we'd have our 4, we'd have our 9, and we'd have open dots, and they'd go towards each other. And so again, these are values found in both inequalities, wherever that overlapping piece is. Now, we also have our OR statements. This is known as our union. Since there usually isn't overlapping, we're looking at just kind of putting them together in the same graph. So x is less than 4, which means on my 4 I'd have an open dot and arrow going towards lower numbers, or x is greater than 9. So I have the 9 and open dot, arrow going towards bigger numbers. And so again, since they're going opposite directions, there is no overlapping, so we kind of smush the two graphs together. And it's which can be found in either inequality, so in one side or the other side, since there is no both, because there's no overlapping. So that's just our little review of our compound inequalities. We're going to go ahead and review practicing how to solve some of these. So our first two are the AND ones. They're put together in the same inequality, and so remember that what you do to one side you have to do to the other two sides here, because there's three sides. So here I'm going to minus 3 on both sides, or all three sides. So now I have 8 is less than 2x is less than 18, and then I divide everything by 2. So then I get 4x and 9. Hey, it's just like our sample problem. And so then on my number line, I'm going to have a 4, 5, 6, 7, 8, 9. And I'm going to have open dots, and we're looking at where they overlap. Okay, so on our next one, I subtract 1 from all three sides. So now I have 4 less than or equal to 4x, which is less than or equal to 12. I divide all three sides by 4. So now I have 1 is less than or equal to x, which is less than or equal to 3. So our x is between 1 and 3. So I'm going to have a 1, 2, and 3. These are closed dots, and I want all numbers that are between those two. So 1.5, 1.9, 2.37845, Yes, I'm just making up random numbers that are in between them. Okay, so our next one is the OR, and this is that union. Usually goes opposite directions. I solve each inequality, and I'm just graphing them on the same graph. And then don't forget that if you're dividing by negative numbers, that you're flipping your inequality sign. So far, we haven't had any of that, so no issues yet, but it's a good reminder to you. So I add 1 to both sides. 4x is greater than 16, divide by 4. I get x is greater than 4. So I'm going to have my negative 1, 0, 1, 2, 3, 4. I want x is greater than 4, so open dot on 4, arrow towards the bigger numbers. X is less than negative 1, open dot on the negative 1, arrow towards the lower numbers. And same thing for our next one. We're going to go ahead, minus 3 on both sides for the first inequality. So now I have 2x is less than or equal to 4, divide by 2. So now I have x is less than or equal to 2. Solve the next one, so minus 5. So 3x is greater than 26. No, wait, 21. Sorry, forgot to subtract. Divide by 3 on both sides, and I get x is greater than 7. Again, looking to graph them on the same graph, 2, 3, 4, 5, 6, 7. I have a closed dot on the 2, arrow goes out. Open dot on the 7, arrow goes out. And so the question I tend to get a lot when we're working on these is what happens if there's not enough dashes on your number line to fit all your numbers? So what if you have 153 and 2040? Then you can go ahead and use just the end ones, or you can space those numbers out appropriately by hundreds or whatever. It's really kind of a choice to you, as long as your numbers are in the correct order. So the lower numbers on the left-hand side and the higher numbers on the right-hand side. That's really what we're looking for, your number sense and understanding where our solutions are. Okay, so special case. Very, very important special case. So we've got several of them. We're going to go ahead and start with the first one. Graph the solutions for x is less than 3 and, so we're looking for overlapping, x is greater than 7. So I'm going to use my 3. I want less than 4, 5, 6, 7. I want greater than. So it looks like an OR problem, but the thing is it's not an OR problem, it's an AND problem. So we're looking for this overlapping that really isn't occurring. So when this overlapping is not occurring, we're going to have no solution because there's no overlapping. Okay, so we have another special case. Graphing solutions of a compounded quality involving OR are not always two separate sets of numbers. There may be numbers that are solutions of both. Okay, so I'm going to go ahead on this first graph. I was wondering why there were two number lines. I'm going to graph x is less than 5. And then I'm going to go ahead and graph x is greater than 3. So 4, 3. And because it's an OR, I'm kind of smushing it all together in one graph. So my final graph is going to be wherever there's a graph on here. So if I look, I've got an arrow here, and it keeps going, and now I'm overlapping. So my graph is here, and I'm smushing it all together. And then what do we notice here? Because this is all one graph now, what's our graph looking like? The entire number line. So this is our final answer, the entire number line, which is many solutions, any real number, that type of statement that illustrates that every number on the number line will be a solution. Okay, so we have one more example of a special case. And again, we've got the two number lines. So we've got x is greater than 5. So here's my 5, open dot, arrow this way. And then I have x is greater than 3. So remember that because this is an OR, we're smushing these together into one graph. So when I'm looking at this, I'm looking at, okay, my graph really starts here, and then it goes, and then it starts overlapping. So it's still going, it's still going, it's still going. So my final graph is really only the open dot on the 3 and arrow going to the right. And it's like that because everything from my second graph here is already included in the other graph. Since it's already included, I don't need to limit anything. It's already taken care of. And so that's our third special case. Now you won't get these a lot. In fact, you'll rarely ever get these, but you will get them every once in a while. So it's important to know how to deal with them when you do encounter them. And so that's why I went over it. Okay, next one, you have a graph, write the inequality. So this one, I've got an open dot and an open dot, and everything in between is shaded. So my x is going to be between -2 and -9. And I can kind of tell because this one lines up really nicely with this one. I've got my -2, and then it goes less than. So it lets me know what direction this one's going, And this one on a compound inequality should go the exact same direction. Okay, on the next one. Now this is not an overlapping. It's two separate ones. So I'm going to go ahead and put my or there to remind myself that it's a union. It's two separate ones that I'm kind of smushing together. And I'm going to go ahead and describe this one. X is greater than or equal to 2. And I'm going to go ahead and describe this one. X is less than or equal to negative 3. And remember, these are solid dots, so we have those or equal to lines. Okay, and that's it for our compound inequalities. One more section to go over, and then we'll have a practice test and a test. And that's going over the absolute value inequality. So if you had a hard time with absolute value in chapter 1, we're seeing those again. They're popping back up. It's your chance to redeem yourself.